Hello and welcome to this week's Wildcard Wednesday. So today we'll be hearing from Abhilash Akar on the Geotab Analytics Lab. So now this is available for free and it's a great way to explore the latest beta experiments created by the Geotab Data and Analytics team. Technical knowledge is not required, which is good news for someone like me. So Abhilash, I turn it over to you.
Great, thank you, Susan. And good morning, good afternoon, evening, depending on where you are. I'm really excited to talk about Analytics Lab today. And, this add-in, as Susan mentioned, is completely free of cost, available in the marketplace. And it's really a great platform to try out, amazing ideas that our data team is working on. And it really has a lot of amazing work that Geotab has been able to create from a data and analytics standpoint. So in the next few slides, I would love to introduce the Analytics Lab as the add-in and also kind of walk through why we are looking into solving some of the problems that we think that big data can lend itself to very well, and also give you some insights around experiments that we have posted in the add-in. And I'll get into these slides that go into the details, and then I would definitely love to wrap up with a few amazing insights that we would love to work on, and also solid next steps that we can kind of continue the conversation. So as you might be already familiar, big data in Geotab is growing. And what that means is we have a growing number of connected vehicles on the road, sending us far more information every single day to the infrastructure we have to collect this data. And this data in itself is just not limited to telematics data in the sense of traditional GPS points, but there's so much more that we get in the sense of acceleration, engine data, and even stuff that is, coming to our data sources that include weather and, other insights that we can create based on this data that kind of relates to understanding traffic, driver behavior, and, amazing use cases in that sense. So this puts us in a very good position to ask ourselves, what do we do with the data that we have? And there's definitely value to be uncovered here. And that is the focus of our team. That is, in the next slide, I would like to introduce the data product discovery team. And our team's function is to actually look at the questions that we can solve for our customers and understand where does the data play a role in there. So, our team really sits at the convergence of bringing in a lot of technical abilities that the data and analytics department is actually putting forth in the sense of, looking at all this data that we get from the devices. How do we kind of channel that into a place where we can actually start working on the data and making sure that, data that comes out is reliable, has a quality, and also can scale with you, right? To be able to handle the amount of growing data that we can get. So, looking at technical side of those things and also facing customers, facing businesses and their problems that they're trying to solve. That's where our team really, focuses on. And we do this by working on, experimental growth opportunities, meaning we want to test new business ideas, product ideas, try to frame hypothesis on here's how we think data is going to help solve a problem. And we go ahead and test those hypotheses with the experiments. And the idea is that, with these experiments, we are bringing new solutions that we think could help solve the problem, but also learn of the gaps that these experiments are not able to solve. And that is really valuable to us to kind of uncover what a product should look like and, take the learnings back to our product teams as well, so that they have insights on here's a set of validated ideas that, we could think of as the next things that Geotab offers to customers at large. I just want to quickly touch upon the kind of backstory behind how this is all coming together in our world. We always want to see the solutions that we're working on as experiments having some kind of outcome bias, meaning there is something that we can measurably improve the problem space or in our customers. So we try to aim for outcomes, and what that means is we're trying to understand what are the metrics, what are the kind of key objectives that your businesses are looking to achieve, and kind of map that out in a visual way for us to link those problems to opportunities that we think are available for us to pursue, and then tie that into kind of broader solutions, drilling it down further into specific experiments within those solutions that can help us understand if that solution is the right solution. If not, what is the learning that we can gain from the experiments that will help us find that right solution. So that's the thought process, that's our approach. We want to kind of keep the outcomes and impact the solutions are able to provide in mind as we go through these kind of experiments, and then how do we think about the next steps once we have learned something from the experiments as well. I'd love to kind of present the analytics lab as it looks today. We've gone through recent UI changes. So if you do install the add-in, you might see a little reimagined front page. But the idea is, here's a great platform for us to bring you these experimental solutions. And just like any other add-in available in Marketplace, you can go to the Marketplace, look for Analytics Lab, and then it should just show up just like a result that any add-in shows up with, and you're able to add that to your My Geotab, and it becomes part of your My Geotab experience. And the idea is, we want to keep this as a platform to bring you experimental applications and APIs. So there's great stuff that comes through the UI side of things, but there's also amazing things that you can do with the APIs. And APIs really bring a lot of flexibility. If you have technical folks on your team, or anybody who's savvy enough to kind of get their hands dirty to actually work with the data in itself, the APIs are a great place to do that. And that's the idea behind us thinking of these experiments, not just as experiments that have kind of an application as like a user interface, but also the APIs in themselves, and being able to allow integrations of these APIs into anything else that you have in solutions as well, any other systems as well. And as mentioned, this is absolutely no cost. Our objective is to learn. As long as we are able to bring these experiments that are meaningful and we are learning from it, I think we are going to have network effects of that passing down to everybody. So it kind of balances out all the investment that the team is making into building these experiments. I would love to kind of touch upon the API Explorer. Like I mentioned, APIs are amazing set of things that will let you kind of take these out of the box and start plugging into your existing systems. So what we've done is, we've hosted all the APIs by themselves into this Explorer view. In some sense, it's very similar to what My Geotab has in the SDK runner and My Geotab SDK documentation. We're trying to kind of replicate that idea here for showcasing APIs that are data focused. And you can explore a whole bunch of APIs here that we have released, in the sense of looking at your road average speeds. You call this API, you pass on some parameters such as, give me the average road speeds of this specific highway or a specific road segment, and boom, you have this distribution of average road speeds of that road segment, right? So that kind of gives you insights on what are the kind of metrics we're able to collect from over various different vehicles that have operated on that road. Intelligent zoning is a great one. I'll talk about that as an experiment in the upcoming slides. Get nearby rest stations, rest areas and fuel stations. These are really interesting APIs that came through some of the COVID response work that our team was able to help support. These are kind of APIs that plug into some solutions that were built for drivers during the COVID lockdown times, when accessing primary essential resources was a little bit of a challenge. So we kind of had data to help in to answer some of those questions around availability of services at gas stations and so on. And fuel benchmarking is another great experiment. It kind of helps us understand where do cost of ownership come from, at least from a fuel perspective. How does that compare with the benchmark that we are able to also create from a data standpoint? So we want to be able to take a look at, hey, here's your fuel consumption, and how does this compare with everybody else that drives a very similar vehicle like yours, operating in a very similar area, and then also having very similar driving mileage and time of day and all that different aspects that we look for benchmarking. So those are some of the APIs. I would definitely encourage you to kind of access the API Explorer, take a look at all the APIs that we have there. These are not just the few that I talked about, but there are a few more that would be great to kind of get to know the APIs and also in process give us feedback on what you find them to be useful. Great. So kind of covered, what Analytics Lab is so far, kind of give you a little perspective on how our team is looking at this to showcase different experimental ideas. In the next few slides, I'd love to kind of deep dive into these experiments themselves. And, I personally, I'm very fond of these experiments because not just, we've seen initial reaction from customers starting to look at these experiments and saying, yeah, this is, very close to what we want, or be very happy to see that this is something that they are now able to do. So I would love to kind of get into those in the next slide, beginning with the next slide that talks about intelligent zoning. One such scenario among a few is imagine a fleet operation that does a lot of different deliveries for a distribution business, and you have a vehicle set of 500 vehicles. So we already are seeing some pain points around planning distribution routes for 500 different vehicles, and there's an objective here that you want to be able to always track and improve your service metrics. So we painted this scenario to kind of elaborate how we frame the problem and how do we define what should be a good solution to address that, right? So the key highlight here is trying to improve those service metrics. So meaning, there's a lot of different components that goes into calculating service times or a drop off at a specific customer location. But one of them is at least the component of vehicles being able to be routed directly to the point where the vehicles need to be, especially a heavy duty truck that might be trying to access the dock area to deliver, the trailer, or, trying to access the back of the building instead of the street address. So that's a problem that we are able to identify here, where street addresses don't necessarily map to where the vehicles stop, especially in this scenario where the stops are for distribution purposes. So presented intelligent zoning as the experimental solution to help with this scenario and a few more that we think this can solve. The idea behind intelligent zoning is how do we look at all the stops that happen in a location and create boxes or shapes around those stops to create these zones that are dynamic, meaning these zones are coming from how your vehicles are actually stopped, how they're actually behaving, instead of trying to create based on addresses. So what this actually enables us to do is, one, solve for that scale problem. You're right off the bat able to create new zones that are directly derived from stock history, and you kind of also get a lot of benefit of getting these zones coming from an accurate source of data, right? You are seeing them come from more recent stops, having more accuracy in where they stop versus what the plan is. So that's where we think this lends to the earlier scenario I was talking about, where we're now able to create these zones that will help distribution use cases where you're trying to create distribution routes that go to these zones, and you're trying to improve the service metrics by directing your vehicles to go to these zones directly instead of trying to have them routed to these street addresses, which adds a little more friction in these vehicles being able to make it to complete the deliveries in the first place. The UI is here. I'm just showing you a few screen grabs of the experiment itself. The way it's laid out is you have these zones that comes up as a recommendation. We have an idea of relevance, based on how many stops we have seen recently, how many vehicles have gone there, and then kind of give you a sense on, hey, we think here's some interesting zones that is kind of most relevant, and you have, from a user perspective, the option to kind of look at them, explore them, and click on a button, and then goes imports into your My Geotab experience. So that point on, it becomes a zone that you can use just like any other zone within My Geotab. So I hope this gives you a little perspective on intelligent zoning. As you can imagine, there's a lot of different use cases this also supports. You can also change the way you create zones as well. You can look for anything that has 2 minutes as a minimum stop requirement, or you could have 2 hours, and then based on that, be able to define, here's my zone, this is what I think should be a zone. Great. So that covered intelligent zoning. The next one I would love to talk about is collision detection. So this is very familiar to most folks. It's such a universal use case to be able to at least manage and track for collisions. And this is very well known pain point, and I don't really necessarily have to talk about the importance of this, but to give a little insight on how we see the outcomes or measure the success is this scenario where you have a fleet administrator who maybe operates or manages over 100 vehicles of a car rental business. So as you can imagine, there's a risk profile associated with rental cars, and it operates and has a different risk profile compared to a distribution company, just like I was highlighting in the previous example. But as you can imagine, now you have this need to be able to monitor for potential collisions. And we do have existing solutions in this space, but then how do we see benefit is to be able to reduce costs associated with rental damages. And that requires collisions to be detected sooner so that you have, from a fleet administrator of this user scenario perspective, the ability to kind of reach out to the renter, connect with them about whether those collisions were truly true, and also provide roadside assistance or customer experience standpoint, being able to provide what they need to, but also take the documentation they need to maybe start tracking towards the insurance workflow or whatever damage workflows the company might have. So that's how we see one scenario that collision detection helps out. So in the next slide, I would love to kind of elaborate more on the solution. And this experimental solution is actually kind of boiled down from a lot of research work that our team in the data and analytics department has been doing to really look at not just acceleration data, but also few other data points that can actually tell us a story whether a specific G-force event was truly a collision or not. So just to give you an example, if the vehicle had a harsh event, but then it didn't stop and it continued to drive away, and then it maybe had a trip maybe for about 2 hours long, then it might be a false positive, meaning it doesn't really look like a collision. It might be somebody kicking the device, or somebody maybe just having a little harsh brake, but not really a collision, right? But then if we have such scenarios where vehicles were traveling and then had a harsh event and then it did not move for next 2 hours, that really has a higher confidence from a model perspective to say that definitely could be a potential collision. So that's what we hope to bring this to the users. Again, there's more than one use case here and user scenarios. So our objective is how do we make detections quicker in such a way that we're able to bring it to the user. We're coming from a data standpoint, so there's a lot of information that the users can tell us if this really was a collision. So we want to be able to bring these detections and have the users tell us, yes, in fact, this was a collision or not. And in that process, also give us additional information that maybe there was a scratch or there was object hit, additional data points that helps us be better in our future detections. So what this allows us to do is, one, improve the model. So the more users are using the models, the better the effects of it. There are more customers who will benefit from having better accuracy in their model collision detections. And also at the same time, we're kind of helping the users take this information to the next step, things that they care about to do once they are aware of a collision, right? So we're also exploring how this kind of a detection piece integrates with first notice of occurrence or first notice of loss perspective from an insurance standpoint as well. So more than a few opportunities for us to kind of pursue further to see how do we integrate this into a bigger solution, larger experience for our customers, especially, trying to manage once there has been a collision and then, all the information has been collected. So yeah, this is collision detection. Again, there's an API in the backend. So the UI, I have the screen grabs here. It shows you one specific event, and the experiments, when you have access to them and you're looking at them, you start getting to see or get a sense of the kind of information that's available. At minimum, we are trying to provide, where it happened, who was involved in it, the VIN number just for identification, and then a little text summary that makes it a little easier to understand the event and the episode of like how did this vehicle come to be in a collision, and some more basic information around the magnitude and possible points of impact as well, which is whether the impact was on the front or right center or rear left, that sort of a thing. I would encourage you to, again, just like intelligent zoning that we looked at, feel free to play with this experiment, provide us feedback. That's really our learning here and the primary objective for us to push for users to tell us if this is giving good detections, and if not, what are the kind of points are we missing? All right, so in the next slide, I would like to talk about, from a safety perspective, some ongoing work that's kind of coming to shape in the contextual risk side of things. Today, this is an API, and it's available part of the API Explorer, as I mentioned earlier. And just to narrate a little bit around contextual index concept itself. The approach that we are taking is, risk is highly contextualized. There's not necessarily one way of looking at certain aspect of a vehicle to say all the risk is coming from that specific point. Rather, it comes from having a good understanding of, is my vehicle safe? Is my driver behavior safe? And also, is the environment or the journey safe? So these are kind of our approach to define the space to say risk for a vehicle or a fleet comes from these three different dimensions in some sense. So we're trying to understand what can data tell us about these three different dimensions. Can we understand, risk metrics from a vehicle driver perspective? Can we understand more about the environment where they drive? So those are the kind of questions we're trying to answer, and we're trying to contextualize it to an additional measure by benchmarking it. So we're trying to tell the whole story around how does your fleet risk metrics look like compared to the benchmark. So just to give an example, a truck driving in a certain zip code may have certain occurrences of harsh events. Now, we know those are risk metrics because harsh events such as, harsh braking and observing harsh braking over time does have, some implications of how the vehicle is being driven and opportunities to kind of improve that driving behavior. But also it could be that there is a benchmarking approach where we can bring in insights like this zip code does have more occurrences of harsh events. So now you're bringing this additional piece of information to that area to say, is it just my fleet that's driving harsh events? And if it's not, then it looks like there are other drivers here that are also experiencing higher events of harsh events. So there could be more than just my driver behavior in question here, but also where is this location? How is the road laid out? What's the road signs? Is it in a neighborhood, in the construction area, or with in a highway? It kind of brings in this additional information that helps you contextualize your risk metrics, and that's our objective with CRI. So just to expand on the idea a little more, there's more than just risk metrics that is associated with harsh events. We want to also be able to do contextual risk metrics and those definitions from vocation perspective, meaning how does your vehicle that operate like in a last mile fashion compared with other fleets that also operate in the last mile fashion? How does that look like from driving in rain? Are you putting your vehicles in conditions where there's a lot of snow and rain compared to other fleets? I think this kind of brings out some more of these insight that contextual risk provides. And all of this is also bringing in the additional data points, like I was talking about earlier, that our devices are bringing in. It's just not about GPS, it's a lot more. We get a lot more information from the vehicles as they get smarter and more sensor data that we can push through, including weather. So those are the kind of insights that we can have from contextual risk. We would love to kind of open the conversation both ways. We would love to hear feedback, as I mentioned, from the experiments, but also we would love to hear about new ideas. We would love to work on things that you pain points that data could be a good solution or help part be of a solution. We'd also encourage you to join the product research panel as well. This forum helps us identifying customers who are willing to have those kind of conversations, and not just from data products perspective, but also from a Geotab product larger discussion as well. Like you could be looking at anywhere, from routing to a mobile experience and all these different areas of product work that Geotab is doing as well. So you could be part of that research panel as well. So with that, I hope this has been helpful to give you a picture about what Analytics Lab is, what are the kind of experiments that are running there, and how you can be part of it and how you can start using this as well. So I'd love to open up to any questions.
Thank you, Abhilash, for such a great presentation. This is such exciting things going on here. We do have a couple of questions. One is, do you have to have a certain fleet size to use the Analytics Lab?
That's a great question. I think it relies more on how much data. We don't necessarily need to have a vehicle count. We just need to have sufficient history in your database for us to be able to create these insights.
Okay, and then once I digest this information a bit more, who can I contact with my questions?
You can reach out directly to your existing support. That could be, your reseller or customer success. But, if you'd like to get in touch with us, you can reach out at analyticslab@geotab.com as well. That leads your questions directly to the team working on Analytics Lab.
Excellent. So that's a wrap for this week's Wildcard Wednesday. And I want to thank you again, Abhilash, for joining us today and sharing this valuable presentation and answering the questions. So until next time, I'm Sue Miller, and on behalf of myself and everyone here at Geotab, I thank you for joining us on today's Wildcard Wednesday. And we'll see you all next time, same Geotab time, same Geotab channel. Thanks, everyone.